Good afternoon, everyone, and welcome to today's Georgia Tech Supply Chain and Logistics Institute Lunch and Learn. I'm Sean McConnell, and I am thrilled to have you to join us for the next hour or so, just exploring some expert insights and professional development. Today, I'm honored to introduce our featured speaker, Melody Shellman, who is an optimization engineer at Ortec, a professional education instructor at Georgia Tech, and probably more importantly, a former Yellow Jacket. Melody is an optimization engineer with experience in data analytics and optimization across many industries, ranging from open source optimization tools in the energy sector to production planning tools in the manufacturing sector, and even donor analytics for an environmental advocacy nonprofit. Most recently, her technical focus has been in modeling for flow optimization, production planning, and scheduling. So today, Melody will be discussing how businesses can leverage data analytics to drive significant improvements in the supply chain performance. So I know that you will find Melody's insights both practical and transformative. And so without further ado, I give you Melody Shellman.
Hello, everyone. Yes, very excited to be here. Thanks for the intro, Sean, and thanks for having me. Really appreciate it. A little bit about me, as Sean mentioned, I am an optimization engineer for Ortec. What that means is we're a company that provides supply chain management solutions using the power of mathematics. It's as nerdy as it sounds. On top of that, I happen to be part of an even nerdier group. I'm part of our consulting division where we develop custom tooling for really more difficult supply chain management challenges or ones that really require some specific analytics tooling that don't happen to be an off-the-shelf type of products. Today, I'm excited to be talking to you about some of my experiences working with different customers in supply chain management. And specifically, I'll be talking about really unlocking the power of data and the evolution of analytics within an organization, starting all the way out from maybe some first analytics products all the way to where we are in trends in industry today. Hope you stick around to the end because I'll be talking about a few key trends that we've been seeing in our customers and topics that we're talking about really driving into in the upcoming years to get ready for the challenges that lie ahead in supply chain management. So to start off, let's set some context. We're talking about supply chain management. Supply chain processes as a whole is a really broad term to describe a very wide range of activities. So something helpful when viewing supply chain through an analytical type of lens is to break it down into these more focused sections of supply chain. And here's one way that we tend to think about it. Of course, there's other ways that you can break it down, and some of it will sound familiar. Some of it will be different in your organizations, but this is how we often think about it. One sector is our demand creation, marketing, and sales. This is looking at questions like, how can we get customers? How do we get customers that are profitable for our business? It often encompasses market research and analysis, sales and marketing, and other groups across the organization. Another section is looking at the inbound logistics, operations, outbound logistics. All these sections cover different types of questions, anywhere from demand fulfillment on the inbound, thinking about the logistics of sourcing and procurement, like identifying your suppliers, negotiating contracts, procuring raw materials. It could be questions like transportation and warehousing, like managing the transportation of raw materials from your production facilities and storing them in warehouses. Other areas, operations side of things, could be looking at production planning and scheduling, which is a lot of the work that I've done on focuses. On the outbound side, could be looking at questions like consumers think about specific regions the most, when and how are the orders getting to them. This could cover topics like distribution, transportation, and delivery, really trying to figure out how do we get the products that customers ordered to them. To set some additional context into the types of problems that we see across supply chain management, we also tend to categorize them in certain ways. Both planning challenges encompass different types of categorization based primarily on the time horizon associated with the challenges and the scope of them. The first one that we tend to see as a specific category is strategic challenges. These are more longer-term time horizons of decision-making, often encompassing multiple years. The scope of the project is generally pretty high level too, so covers system-wide, impacts the entire network strategy. On the opposite end of the spectrum, which I'll pull both of these out on the slide here. On the opposite end of the spectrum, we have operational type challenges, and these are more on the short-term time horizon. So focused on daily challenges, weekly decisions that need to be made, and are usually on much smaller scope. So focusing potentially on one region of a supply chain. In the center, we have tactical planning, which tend to fall somewhere in between strategic and operational. And a lot of times there's not really a strict definition into how we classify one or the other. But classifying them in these categories helps us determine how to tackle them in an analytics format. This leads us to introducing 4 different primary types of analytics, which we'll get into talking about how it fits into the evolution of the supply chain. But there are 4 main types of analytics, and I'll actually hint at a 5th one at the end of today where the world is moving towards. But starting with the 4, these are descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive. They differ in the types of questions that they can answer. They also differ in the level of impact that can be made, and the type of analytics that are typically used to draw these types of analytics and conclusions. Let's start maybe by looking at some specific examples of planning challenges. We'll focus on a couple of them that I'll use as examples throughout the rest of today's webinar. So starting with some examples of planning challenges and analytical solutions at each level of planning, the strategic, tactical, and operations level. Actually, I'll pull back so we can focus on one at a time. We'll also relate each of these examples to which region they're most closely related to. So the graphic on the left serves as kind of our axis and spectrum. And as you saw, as I pulled it all out, it goes from strategy or type level of challenge to tactical and then to operational level of challenge. Items closer to the top are typically closer to those longer time horizons, bigger scope of focus. And of course, as you go down to operational, that's again closer to more day-to-day type operational level type challenges, and that typically have more narrow focus. As we go through examples on the right, you'll see that sometimes there's a blurry vision between what categories they typically fall in. But generally, it's a useful tool to keep in mind in terms of thinking about what analytics will be useful to apply. So some examples starting with the strategy. Supply chain design is a really classic example of strategic level decision making. So asking questions like, how do I design my network to support the anticipated growth of my organization for the next X years, maybe 10 years? This is at a strategic level because it really affects the full network system and is a decision that's made for long time horizons. There's a couple other 2 that we have classified under strategy: warehouse design and factory layout. They tend to have similar questions to supply chain design, but they focus on maybe a specific facility of the network. They look at finding the best positioning of storage space per products, or maybe it's machinery too. We have it here lower a bit on the spectrum just because it tends to cover a smaller portion of the supply chain network. The next section is looking more so on the tactical side and examples here. These tend to be types of challenges that are maybe setting policies and procedures to support strategy. They might affect monthly level decisions, or maybe it could lead to day-to-day decisions as well. We have the examples that we have tend to fall closer to the marketing and sales or demand creation side of the challenges. These are things like product recommendation, where we're asking the question of which product should we offer to customers, where and at what time point. This could be things like cost to serve, like what does it cost to deliver a product to X customer. Topics could also include looking at customer churn, which customers churn, and is there a specific reason why that they do, and revenue management, looking at things like what price points should I set my products and what price points would be most profitable for my organization. The last group of examples that we have here is looking at the operational level. These challenges, again, are focusing really on carrying out the policies and procedures that support the strategy that's been set by these kind of strategy and tactical challenges, but more so focus on the shorter term. Examples here could be inventory management. This one creeps a little bit more towards the tactical side of things because I think there's a strategy focus that need to be set with inventory management. But then, of course, there's the day-to-day actions that need to happen with your inventory policies. In general, for inventory management, it could look at specific things like handling restocks, avoiding stockouts. The scope of it could be bigger or smaller. The time horizon could be bigger or smaller too. It could be on one specific regional level, or it could be on a global level even. So that one tends to fall closer to operational, but could be seen across the board on this chart. Performance analysis could be something like looking at how our supply chain is performing. Production planning could be how much should we produce today? How much should we produce tomorrow? Predictive maintenance, route optimization, workforce scheduling, all of these things tend to focus on more operational day-to-day type of questions like the maintenance of our vehicles, what routes should be taken to deliver the orders that our customers have set out. Also, workforce scheduling could be looking at who should be working at what time point and when. I am going to talk about 3 specific challenges in a little bit more detail because we'll be using that as motivation for talking about the evolution of analytics for each of these 3 specific types of challenges. Maybe it's something that you noticed in how I described the challenges in last sessions, but we'll give a little bit more detail here already. So starting with the first challenge, this one we'll categorize as cost to serve. So really trying to understand what does it cost to deliver a product to a specific customer. This falls really on the marketing and sales side of the supply chain and focuses on that demand planning portion. Another example, the second challenge that we'll focus on is looking at predictive maintenance. This predictive maintenance answers specifically the question, when should we be performing maintenance tasks? So this could be for the trucks that we have in our system. It could be for machinery on our production line. There's plenty of things that require maintenance, but how can we specifically apply this maybe to one area of our organization? The last one that we'll use as motivation today is route optimization. So specifically looking at how do I route my trucks in order to deliver to the demand that the customers have set out. There's, I think, a couple of questions that go along with it, like how many trucks should I have? Where should they be? But the one that we'll focus on mostly here is the specific aspect of route optimization. Which route should they take to get there? So with these first couple of slides that I mentioned here, we've kind of set the stage for understanding different supply chain challenges. We introduced these 3 that we'll use as motivation for the rest of today. And next here, I'll move into talking about really what the evolution of analytics could look like within a supply chain management organization. And with that, I'm introducing something that we call the analytics continuum. It's something that has been introduced for quite some time. It's been reworked many times too by different people, but generally it's proposed like this. On a chart where we see the x-axis as effort and the y-axis as impact. So effort meaning how much does it take for us to apply a certain type of analytics, and impact meaning how much does this really impact our organization? What can we get out of it? There's 4 distinct types, which I hinted at the beginning of today, that I'll introduce here, and we'll go through some in-depth examples of what these analytics look like for the 3 challenges that I just talked about. The first is descriptive analytics. Descriptive analytics typically tends to look at what is happening in our system. It could be things as simple as summary statistics to get a summary of the delivery time or the time that we're late for delivering an order. It could also encompass things like in your inventory, like what's my average inventory levels? How many stockouts do I have? In other areas for like the cost to serve type of focus, could specifically look at what is it costing me in total to deliver to all my customers. So really getting understanding for what is happening in my system. The next type of analytics is called diagnostic analytics, and it's more so focused on why exactly is it happening. So perhaps we're delivering to two separate customers. One customer we're always late for. Diagnostic analytics would look at understanding why are we consistently late to delivering, or is it that we are actually consistently delivering late at all? The next stage of analytics that companies tend to trend towards from descriptive and diagnostic analytics is what we call predictive analytics, and looks at what will happen in the future. I think the classic examples that we tend to hear about and see commonly in supply chain management, it's like forecasting. So predicting what will be to come for demand, or predicting when we might have a stock out. Really getting prepared for what is happening the next day. The last stage, which, spoiler alert, it won't be the last one that I mentioned today, but the last kind of basic stage that is introduced in the analytics continuum is prescriptive analytics. And this is specifically looking at what choice should be made, or what are the different options that could be made and which one is the best for me. So it's going beyond what's happening, why is it happening, what is going to happen, but further is making the step of proposing a potential solution or the best option ahead. We'll go into more detail for both, starting with unpacking descriptive analytics. Like I mentioned, descriptive analytics tends to answer questions about what happened or what is happening. Primarily, it's based on historical data within a system. And oftentimes, the analytics is either called business intelligence and is proposed in some type of dashboards. If there's any analytics at all at an organization, it likely falls under descriptive analytics. Most companies have adopted some form of dashboards to monitor the current status of various areas of the supply chain network. They may not all be integrated in one place, but for the most part, a lot of organizations have already some sort of monitoring going on. How does descriptive analytics specifically apply to the three challenges that we identified earlier? So like we talked about earlier, we have cost to serve, we have maintenance, the maintenance, predictive maintenance challenge, and then also specifically looking at routing. Descriptive analytics on the cost to serve side, we'll look at summarizing some basic costs from supplier, production, inventory, warehouse, route costs. On the maintenance side, I could look at summarizing the tasks that are being performed for maintenance already, documenting the equipment types that already require maintenance, and perhaps even also monitoring the amount of downtime and costs that we see incurred from the outages of specific trucks or the specific machinery that we have in our system. On the routing side, it could be summarizing the route distance, volume, summarizing the resource usage and utilization of the resources that we have across the organization. This is not by any means a complete list of all descriptive statistics that are applied to these challenges, more so just an illustration of what those could be. Moving on to diagnostic analytics, here we're really trying to understand why are things happening in the system. This too tends to be focused on historical data, and the benefits tend to help users understand the forces that are acting on a business, maybe external forces or internal behavior of people within the organization that cause something to happen. Similarly, it's also tends to be called business intelligence, and a lot of times is shown in dashboards. Maybe one extra element to it though, in the first step where we're looking at descriptive analytics, it might be a summary of stats, it might be a table, it might be a nice chart that shows things, but in the diagnostic analytics element, we might be looking at maybe correlation between different variables. So charts with multiple variables, or charts that encompass maybe a map that has demand plotted against it. So you can maybe make some assumptions of regional demand in one place or another. To maybe compare and contrast the two descriptive and diagnostic analytics, on the descriptive side, we're more so looking at observing whether that be observing some sort of pattern or observing some sort of correlation. Diagnostics, on the other hand, is more so trying to understand what that pattern is, understanding what that correlation is. As you might imagine, if you think back to your college statistics class, looking at the t-test, z-test, those types of things, those are the types of things that we tend to see in diagnostic, along with maybe some visualizations or other formal analytics. What are some examples of how this looks like for those three challenges? On the cost to serve size, diagnostic analytics could look at looking at the production costs against the volume and product type. It could be looking at inventory cost versus demand, route cost versus distance, really trying to get an understanding of what are the relationships between the variables that affect my system. Maintenance and routing will find similar things. For maintenance, we want to get maybe an understanding of how equipment failures relate to the volume of running time that we have for machines, or maybe how they relate to certain machine settings that we set for the machinery on our production line. On the routing side, this could be more so looking at our distance versus volume versus cost, getting an understanding of the planned delivery times versus actuals, or planned delivery length versus actuals, see if maybe there's a relationship there. Of course, there are others as well. The third type of analytics that are kind of in this continuum and this evolution of getting more and more sophisticated with our analytics that are requiring more effort, more impact, is something that we call predictive analytics. And this one probably really resonates most with some of the hotter topics today. It's related to really trying to understand what will happen tomorrow, or what is going to happen based off of what we already know. This, a lot of times, predictive modeling is specifically associated with machine learning or simulation. Some classic machine learning applications to forecasting or to predictive analytics is looking at something like forecasting. Forecasting inventory, forecasting demand, could be done with some machine learning type models. Simulation is also mentioned here. Simulation could be the case where we come up with a digital twin of our system, really try to mimic the patterns that we see day to day, but apply maybe a potential or maybe current processes and see what might happen as we make potential changes to various futures and how that affects our system. This also falls under predictive analytics. For predictive analytics, how does this apply for cost to serve? It might look something like predicting the impact of individual characteristics to cost, which I'll give an example of how we apply that at Ortec right after this slide. It could also be predicting the expected future costs that we might anticipate within our system. For maintenance, it might be asking the question and looking more so into when can we expect our equipment to fail. Earlier, we were trying to understand a connection, but now we really want to get an understanding of when might that actually happen. On the routing side, we might be looking more so at predicting the future demand based on the historic demand that we've seen. We could also be able to look at predicting the stop time durations for a customer based on the planned versus actuals that we've seen historically in the past. As promised, I wanted to give maybe a more in-depth look at this cost to serve example on the predictive level. And this is something that we specifically do at Ortec all the time for our customers. And this is the flow of how it tends to look. So we're talking about cost to serve here. So there's a couple of steps that we go through in order to, one, be able to determine what those costs are, and two, be able to drive value for customers that are actually using these types of tools. So it starts with really determining the total cost to serve. So if I have 10 customers, how much does it cost to serve the 10 customers on this day with this vehicle? Next, we look at trying to identify the specific cost impact of maybe specific characteristics. Maybe it's the cost characteristics of the drive time between customers. Maybe it's the volume of material that we're delivering. Next, we move into really trying to allocate the cost to individual customer deliveries. So these two steps are really where we're looking at kind of that between the diagnostic and then moving into predictive. So getting understanding of what the costs are, where they're coming from, and then also using the allocation to predict and apply it to the specific individual customer level. With all these steps, we can make a prediction or an estimate for how much cost is associated with an individual customer delivery. And that can be used as motivation for the customer, for the organization to have conversations with customers to try to balance the service levels, balance the cost efficiencies. To give some specific examples of what that looks like, the data that comes out of this could be used for motivation and conversations to talk about maybe reducing the number of visits per customer, maybe negotiating larger service windows so you have more flexibility on your routing, reassigning customers to different depots if that maybe is more cost effective. Could also be increasing sales footprint in customer regions and installing some set minimum order values. You'll see a quote that was here. I pulled this from a colleague of mine that I happened to see this presentation for. I also saw it was crazy. For one of the companies that we've applied this to, there were savings seed of over 1 million, which sounds a bit ridiculous. I thought that too, but digging into it a little bit more, being able to negotiate these types of things with data-driven value could really lead to these types of results. Before I talk about the last one, prescriptive analytics, I also want to give a quick aside that I think when we talk about the analytics continuum and talk about maybe the evolution of analytics, the assumption or the implied meaning is that, oh, we should really be moving towards all our analytics being in these final stages. I don't think that's necessarily true. I think there's lots of value that can be derived from every step of the way for all 4 of these aspects of the analytics continuum. And I think there's also a detriment too sometimes when we focus really on the fanciest technologies and the fanciest things to be applying when really we can get the same impact or impact at a lower effort at earlier types of analytics. The last example that I gave with the cost to serve really does not reach the prescriptive analytics type. There's no suggestion on what specific choices should be made, only the data provided with the predictive analytics to give power to the supply chain managers to make decisions on what to do next. So that's a good example of how something that's really a really powerful example really falls still under predictive analytics, not even the furthest of them. But moving to talk prescriptive analytics, this one happens to be my favorite and happens to be where I spend most of my time. As an optimization engineer, our work really focuses on trying to understand what's the best possible decision that could be made given the situation that we're in now. And that's exactly what prescriptive analytics does. It really asks and addresses the question, what different choices could we be making? In prescriptive analytics, we also tend to look at historical data input and or could also be predictions input, which I'll talk a little bit about how these two connect later. It's likely optimization models, reinforcement learning agents. When you think of maybe the more advanced analytics, it's likely to fall under here because it's really doing taking data that we have and making recommendations for what decisions to actually be made. Specifically, what type of specific analytics or questions can be answered with prescriptive analytics and the 3 challenges. For cost to serve, it could be taking what I showed you to the next level. So not only allocating costs to specific individuals and using some prediction power for that, but also making decisions of how to actually balance cost and customer service to maybe determine the right price, to determine the time windows that we're open and flexible to offer. For maintenance, this could be also going a step further from not only predicting when machines will fail, but also being able to determine a specific maintenance plan. Like if we know that the machine is going to fail at an X point, what choices can we make 1 week ahead, 2 weeks ahead of this predicted failure to be able to avoid that? For the routing side, I think optimization, predictive, or prescriptive analytics really classically applies to routing. So looking at things like creating optimal routes, being able to create a resource schedule, so figuring out what's the optimal schedule for each of my drivers to be working. Determine to also if there's a need for having flexible resources available in case there's some reason that we need them. A little comparison between the predictive and prescriptive. The predictive side really is trying to make some sort of decisions based on forecasted outcomes, whereas on the prescriptive side, we're able to also make decisions to change the forecasted outcomes. So predictive, we might be able to predict a bad future, but we don't have the specific analytics to tell us what to do about that. With prescriptive, we do. We could predict a bad future and say, this is the plan for how to prevent that bad future or be able to address it effectively. This here shows kind of the traditional conceptual process for an analytics project, the 5 stages that we tend to follow when developing these analytic type projects. It's very basic, and I think when looking at it, it makes a lot of sense. But for looking at an analytics project for the first time, some of these steps may be missed. The first step, of course, is always to come up with the specific challenges, defining the specific problems that we're trying to address. Also understanding what is the need of maybe addressing this type of challenge. I know that I've been on projects in my career where we've maybe answered challenges that didn't necessarily need answering, or they weren't properly defined at the beginning in a way that would really lead us to impact and improvement for the organization as a whole. So the biggest learning I think that I've had maybe in the past couple of years of my career is that this idea creation stage is really key. It's probably natural for the nerdy folk like me to get excited for the later stages of analytics and things and forget the early steps. So maybe that doesn't apply to you, but a reminder that I always give myself is really trying to go answer the why. Why are we answering this question? What will it bring for our organization? What impact will it have? And why should we be doing it? The next stages focus more, I guess, on the technical way of addressing it, the technical processes that we tend to follow. The first step of the technical side is data pre-processing. So if you have any amount of data in your organization, if you've spent any amount of time messing with that data or processing it in some way, you are aware that data can be very messy. Also, obtaining the data too can be very difficult sometimes. So we usually have a very protected time and dedicated step to this data pre-processing step where we focus on gathering all the data that we require, cleaning it to a way that we're able to process it. And this specifically could mean handling missing data, handling outliers that we see, any errors that we have in the data, which there are always tons. The next stages might look more so at kind of the early stages of the analytics continuum that I showed. We call this exploratory data analysis, and it's focused on some like descriptive analytics, particularly descriptive statistics like means, standard deviations, variation, that type of thing, to get a feeling for what am I actually looking at in my system. A lot of times too, this is paired with developing visualizations, which are helpful for driving insight. Once we have that ready to go, we're able to do our model and analyze, apply one of or multiple of the analytics types that we talked about earlier. And all that together kind of sets us up for further analytics too, which could really be anywhere across the 4 analytics types that we discussed already today. With the last sections of today, I wanted to talk about some of the trends that I feel go beyond the analytics continuum that we talked about here, and are something that we, as an organization at Ortec, are really focused on building out in order to support our customers in the future. These are two things. One I don't think you'll find surprising. The first is something that is called cognitive analytics, but really how you'll probably recognize it is generative AI, the chat GPTs, and applications of that to supply chain management. The second one is what I call analytics working together. An example of this is how do our predictive analytics and prescriptive analytics working together? And this is something that I've been seeing more and more of, and I think really will continue this way. A lot of organizations have already applied these different types of analytics. They might live pretty separate right now, but they certainly are there. I think a next further stage is to think about how these connect to one another. And I'll give some examples of that here in a minute. Yes, this is the examples that I was looking to show here. So maybe how do our predictive analytics feed into our prescriptive analytics, or how do they work together? Maybe a concrete example of that that I've seen, I think multiple examples of, is something like inventory management. With inventory management, we need to understand what is the demand that is being set by our customers, but we all know that demand is not something that is usually set. Usually there's some variability in that, and we use some sort of forecasting or predictive model to get an understanding of what the forecast might be in the future. Prescriptive analytics, of course, with inventory is going to be saying how much inventory should I keep at what time point, what should be moved when and where. And the natural feed into that type of analytics is a forecast. So our predictive analytics of the future can be something that is fed into an optimization model or prescriptive analytics that makes decisions of our inventory policy. So really a concrete example of how these all are connecting to one another. The second that I talked about is the cognitive analytics, or like generative AI. I would classify this as the high effort, high impact, probably pretty even far above where the rest of them lie. I don't think it's a linear map here, but it's definitely the trend that we're moving in. And you've probably seen all over LinkedIn, all over your social medias as well. But here we're really trying to get an understanding of how do we make some sort of meaning of the data. Of course, that's really the ultimate goal of all 4 steps of the way, but cognitive analytics is really inherently doing that with machine learning tools, generative AI tools that act in almost a human-like way. I think really the future, and something that we're working on building on at Ortec 2 is talking about how all of these connect with one another. How do our diagnostic analytics feed into cognitive analytics? How does predictive, prescriptive, how do they all feed into each other to really empower us to make data-driven decisions and improve the supply chain management systems that we have? This is a more descriptive example of the one that I shared earlier that talks about an example of how predictive and prescriptive analytics connect to one another. This follows the thought that in optimization models, in prescriptive analytics, there's a lot of uncertainty into the data that we feed into that. And maybe we can use things like our predictive analytics, like machine learning, in order to inform those. So this first line here is kind of the classical example of looking at predicting something, then optimizing on it. We start with some basic data. We use something like machine learning models or statistical models to do some sort of forecasting on that. Here we can generate a frozen point in time estimate of what we think will happen out in the future, maybe 1 month from now. That can be fed into our optimization models to make decisions around. But with that frozen point in time of the forecast, things are constantly changing. Oftentimes, this can lead to kind of efficient and fragile decisions. The step that and I'm excited for because we're developing maybe some thoughts around this specifically, that is really moving into a world where we're able to kind of incorporate this uncertainty. So we have some sort of data. We develop some sort of machine learning, and this machine learning can not only have a frozen point in time prediction of our forecast, but also maybe give us some probabilities around it. What is the likelihood that that the demand falls within a certain range for the next future days? We can then use this to power some really fancy prescriptive analytics that we call stochastic optimization that's really able to take those uncertainties from the forecast and make more robust decision making. This is the trend that I see for our future and am very excited about. A few more comments on how generative AI fits in with all this. So we just talked about the example here of maybe incorporating some machine learning, some prescriptive analytics all together to drive some decisions. But some applications of generative AI could be things like some sort of conversational UI. So not only do we see dashboards, interactive optimization models to make decisions, but generative AI could come in and be able to help answer specific questions, drive specific actionable insights, summarize certain findings in ways that are now just coming to fruition. Generative AI could also be applied to automating some repetitive tasks. Could be something like a specific information exchange between one place and another, preparing certain meetings, interpreting events. But really, I think the emphasis is on the bottom here of what we're thinking about on our side is questions for identifying the use cases of generative AI. And these could be things like what insights are in the data, what is difficult to obtain with the available screens and dashboards that we already have that we can't make meaning of because we only have so much that we can process at one time as humans. What insights are not in structured data, but do affect supply chain performance? What repetitive time-consuming tasks would benefit from automation? All of these are really things that we're starting to think about generative AI use cases and hope this can help you think about where it might be useful in your organization as well. I have a few closing thoughts for today to summarize what we've been talking about here. The first really is that the evolution of analytics at an organization could follow something like this analytics continuum that we showed. The emphasis that I want to show here too is that you don't drive all your insights from the fanciest of the fanciest techniques. Though there can be more impact that's seen at these later stages of the continuum, like predictive and prescriptive analytics, I think there's lots of key value that can still be found at descriptive and diagnostic analytics. So not necessarily the case to jump all the way to the end as fast as possible. Going beyond the continuum, I think there's a couple things that are trending in industry today. The first, as we all know, is that cognitive analytics and applications of generative AI are really coming about and figuring out ways of how to maximize that value within your organization, I think, is becoming more important than ever. And lastly, the combination of these analytics, I think, too, is really becoming key. I think really organizations today are really sophisticated in having, most are really sophisticated in having these separate types of analytics already, but thinking about how to pull these together in combination, I think really can drive the future. With that, that's all that I wanted to share today. Hope you guys got something useful out of it. If you're interested to learn more, have questions or anything, feel free to reach out to me on LinkedIn. Thanks for joining, but I'll pass it over to Sean now for some closing thoughts from his end.
Yeah, thank you, Melody, both for the incredible insights and for letting us know a little bit about what might be to come beyond that analytics continuum. We did have a couple questions, if you've got a second, that you might be able to answer. The first one was, how does diagnostic analytics help us identify the root cause of a problem? Also, how can we ensure that the output of those predictive analytics is accurate?
Yeah, these are good questions. So on the diagnostic side, how can we specifically use these to figure out the root cause of the problem? A lot of it is looking at some types of correlations. Could be just starting with some general exploration of what do the visuals look like of correlations between different variables in my system. There's further statistical techniques that can be used to have a more definitive answer of yes or no, there's some correlation between the two. But as I think your question alludes to, correlation does not equal causation. So a lot of times it can lead to hints at maybe where the root cause might be, but I think some human insight is still needed to be able to really drive that answer. The second question, which was about the accuracy of our prescriptive analytics, That also really depends on the type of analytics that we're using. I think in those types of cases where we're developing maybe a forecast for the future, we don't typically tend to look at one type of analytics or one type of machine learning. We tend to explore a number of them, see how they perform on data sets that maybe we've left out, or data sets that maybe we've set up to mimic the future of some sort, and we can see what those performances look like and maybe average them across the different data sets that we've used it against. Hopefully that answers the question.
And we've got one more. Could you explain how software powered by AI can deliver predictive or prescriptive solutions for warehouse activities? And I know that's
Okay.
a detailed question for you, so.
Yeah. Could you maybe repeat it one more time?
Yeah, so and it's in the Q&A if you want to read it, because it's a pretty robust question, but I want to make sure that we address it. The idea
Yeah.
of explaining how software powered by AI can deliver predictive or prescriptive solutions for warehouse activities.
Okay, so the question is looking at how can AI be useful, particularly around predictive and prescriptive analytics within like warehouse activity. I think there's lots and lots of applications within the warehouse, and I think that comes from there's lots of resources within a warehouse setting. There's also, of course, all your product that's moving around one or another. The classic example that I think of for prescriptive analytics is that warehouse layout optimization. So in a warehouse, there's lots of options of how you can lay it out in a way that may be efficient or not. And using something like prescriptive analytics can pull in what is the layout or what is the area that I have to work with, what are the requirements of where things need to be placed, and output things like this is where we should put these types of products versus this is where we should put other types of products. I think there's further applications of that too on like the prescriptive side. I think having a really good hold of the demand and really good hold too of how the demand specifically relates to your warehouse could be effective uses of AI in that case.
Fantastic, thank you. Before we wrap up, I want to connect today's learning to an important opportunity. If you found today's content valuable, I'm excited to highlight our supply chain analytics certification. And so this is a 4-course program that is tailored essentially for business professionals who either perform in their job or would like to perform data analysis of supply chain. And so it uses a lot of leading edge analytics to address the full complexity of an organization's supply chain. The first course within the SCA certificate is transforming supply chain management and performance analysis. And that's going to run January 27th through the 30th. And our own Melody Shellman is the instructor for that. And so if that is something that you're interested in, you can check out our website. Also, it is a hyperlink. So in this PDF that we'll be sending out early next week, you can click on that link. It'll take you directly to the registration page. If the idea of generative AI made you excited, looking ahead, our next Lunch and Learn is on January 2nd at noon Eastern Standard Time, and it's going to feature a deep dive into how artificial intelligence is optimizing supply chain efficiency. And so industry experts, Chris Gaffney and Fred Benevin, are going to touch on generative AI fundamentals, prompt engineering, and practical applications like automated inventory, predictive maintenance, and route optimization. And they'll also touch on some best practices for generative AI with supply chain use cases. So mark your calendars for January 2nd at noon Eastern Standard Time. It promises to be another can't miss session. And so that registration link is up here. You'll be able to click, or if you just can't wait until early next week to register, you can use the QR code. Finally, thanks everyone for joining us today. Thank you for investing your lunch hour in professional growth. Your commitment to continuous learning is what makes the supply chain community so dynamic. So some quick reminders, the recording and the PDF of this slide deck will be emailed early next week. You can check out our website, scl.gatech.edu, for more information on our supply chain analytics certification. And don't miss our upcoming course and Lunch and Learn coming out on January 2nd. So until then, stay curious, and we'll see you next time.
Hey, sorry, Melody, I saw a question come in if you just have a minute or two.
Sure.
Has geospatial analysis been used in supply chain and logistics analysis?
Oh, that's a good question. I personally don't have a lot of experience specifically with geospatial analysis, but I do know that like some of the routing software that we have takes into account some things. I don't know if like traffic and things incorporated specifically with geospatial analysis, but I think there's definitely ways that that has been applied. I just am not super familiar with it.
Okay, thank you.
And the final question that just came in, there is a discount of 17% for individuals that register for all 4 courses of the supply chain analytics course. If you register for all of them at the same time, there is a 17% discount. And the details of that we will include in this outgoing email. So with that being said, thank you guys for your time, and we'll see you next time.